Now, let me say as an introduction, we're going to talk a lot about capacity mechanisms or capacity markets. Are they necessary or not during the day? We are currently at the stage of finalizing a report to the German Federal Ministry of Economics on this very issue, which is going to be published most probably on the 20th of April. So as this is not yet published, I need to be a little bit, or I'm a little bit reluctant to talk about that very specific questions about do we need a capacity market, at least for Germany, and if so, how should it look like. But I think there are many other important questions that are sort of related to that, which needs to be discussed if we talk about, I mean, we are in the process of the transformation of an energy system. And now we have liberalized the market. Now we're talking about do we need more coordination or more central planning? I mean, it's interesting to see that the discussion goes into the direction of more planning or more state interference in various aspects. I mean, a capacity market would be one. I mean, if you look at the German discussion, and if you go to, probably many of you have been to various conferences, and I mean, in the beginning of this year at the big energy conference of the Handelsblatt in Berlin, they made some sort of ask question, what is the most important thing that the Energiewende, so the transformation of the energy system in Germany needs? And what was stated most frequently was we need a master plan for the transformation of the energy system. We need a central planner. We need an energy ministry. So this was not about what we actually need in terms of which kind of mechanism, but it was I don't know whether this is specific German, it was the call for somebody who says that's the plan and this is how we're going to proceed. Now, what we do at the EWI, at the Energy Institute at the University of Cologne, we usually do sort of simulation exercises about how least cost development of capacity would look like, and this is one of these calculations, how least cost development of a generation portfolio would look like. So how to meet a certain level of security of supply meeting this historical peak demand. And so, I mean, the key point, and we are not by far not the first, and you're well aware of that. The key point is, I mean, what more or less all of these cost minimizing simulation tools say is we're going to need additionally gas-fired power plants, or to be even more precise, gas turbines. Gas turbines as a backup technology, as the cheapest backup technology for the very challenge that we need to, in order to, if we impose a certain level of security of supply, to reach that level of security of supply, we need some backup technology in a system with a high share of renewables. And so this would be gas-fired power plants, and we all know that this is sort of the core of the discussion. How could these gas-fired power plants be financed in an energy-only market? Well, this is on the aggregate level. What I want to stress more is, I mean, below the aggregate level, there is an additional challenge on the regional level. So if we look at the regional level, you can see, I mean, this is sort of a rough, but at least at some degree, a regionalized view on Germany. Where do these capacities actually, I mean, these capacities in 2010, where are they actually located? So where are they actually located, and how do they actually look like? Well, they are located in the west of Germany, in particular lignite, and there's some lignite centered also in eastern Germany, where there is where the resources are. And I mean, clearly one of the main challenges that we see in Germany is that we have a large chunk of nuclear power in the southern part of Germany, and you already alluded to that. And this is sort of, that's it's not the total capacity which poses a challenge to Germany, but it's the regional dimension which poses a challenge. So if we take out 7 to 8 gigawatt in 2010, this picture tells you, well, this is not at all a problem, and this picture tells you it is a problem because we take it out very focused in one part of Germany, without, we know, at the same time extending the grid that additional electricity could come from the north to southern Germany. This is even more important as you know, renewables are, in their location, follow where the resources for renewables are. The key renewable resource clearly is wind in Germany, so wind is in the north. It's not in the south, so it's not able to quickly replace, at least in terms of pure capacity. Well, not at all in terms of reliability, but in pure capacity, what we have taken out in the south. Well, we do not want to focus too much on photovoltaics, but we know that photovoltaics is mainly in the southern part of Germany. Now, this is the status quo. This is how, sort of, again, a look into the future on a regionalized level. If we would add the capacity, which is, I mean, here we have sort of added capacity in our simulation tools, and we would add this conventional capacity. Well, where is this going to be built? I don't know. Yeah? So, but let's assume that it's going to be built where the old capacities were also built. And I mean, for some of the resources, it's quite clear. Lignite can only build where already lignite is, where the resources are. For the other, it's not so clear where they're going to be built. We'll talk about that later. But I mean, this is if we would add them where they are already located. What is far more important is where does the addition of renewables will be located, and how much is this going to be, and what is this going to be? If Germany wants to meet its targets in terms of renewable targets and in terms of CO2 emissions, it will be loads of wind and will be loads of offshore wind. You know, nobody knows whether this will ever come, but this is at least, if we want to achieve our targets, this would be sort of the idea where in a least cost solution this should be located. This is in terms of capacity, where this is going to be located. Well, what does this imply on the regional level for the exchange between the different regions just on the German level, not to talk about the European level? So we will have regional imports and exports, and clearly we have regional imports, exports where we will have all this excess capacity, wind capacity in the north, because there's little load there, and we will have all these additional wind produced in the north, and so there will be loads of export from the north. What does that imply for the coordination with the grid? Clearly, we will have put stress on the electricity grid. You see indicated in red, this will be the lines which will be stressed most in the energy system. This is the big challenge if you leave the aggregate level where you say, okay, this is the peak demand for Germany, and this is the amount of capacity which we need to meet that. The capacity needs to be located somewhere, and it needs to be coordinated with the grid. And so this is, to summarize, I would say what I would like to stress is that these regional aspects are an important additional aspect, and it's that these regional, in particular the regional aspects that call for coordination between where is generation going to be located, where are networks going to be extended, is something which clearly calls for some way of coordination, because it's not so clear how this is going to be coordinated right now. So I mean, there are ideas about platforms where the different parties talk about that. It's not so clear what the incentives of the parties are to really contribute to a coordinated solution. The key point being, from my perspective, is that, I mean, for the grid investments are heavily regulated. We have investment budgets in Germany that incentivize additional grid investments. This is subject to a lot of regulatory interference. We have generation investments which are not subject to a lot of interference, even if we subsidize a capacity. It's not so clear whether we do it like, say, in Spain, that we just give a subsidy and then people build wherever they like. Then we don't have a control where they're going to build. And this could obviously create problems. But I mean, the key idea is that generation investment should be driven by the market, or by a market, not so much in a regulated way. Okay, just to, as a brief sort of let me present you a simple sort of model that tries to highlight where I see sort of key inevitable challenges when we talk about coordination of grid investments and generation investments. And for the sake of making my argument, let me show you an extremely simplified model of the world. So my world has only two regions, not that many regions are shown you in Germany and not the whole EU and so on. There are only two regions which I call North and South. And let's imagine that in these regions there are already existing power plants, say of size 1 in each of the two regions. There's only one period, there's only one point in time where demand realizes in the north and in the south, and demand can either be high or low. We do not know yet how demand develops in the two different regions. So demand might be either high or low in the north. High would be it is 1. So the north has installed already 1 unit of capacity, so it could always meet its own demand. We will probably in Germany not have a shortage of electricity generation in the north of Germany, but we could have an excess production, exports, as I'd shown you. And we have a southern region which has, on average, higher demand. But demand could also be either high, it would then be 2, or low, 1. The south has also installed 1 unit of capacity, so there should be a shortage in the south if demand exceeds the installed capacity or not. And so we could add capacity either in the north or in the south, where capacity in the south is more expensive than in the north, or we could hook up the two regions. So, at the status quo, they are not linked, so there's no electricity exchange. There are electricity markets in both of the two regions, and there are regional prices in my simplified world here. So there's the price in the north and the price in the south, as long as the two regions are not linked. Prices follow basically the idea of shortage. So if demand equals supply, then we will have some positive electricity price, which I call lowercase m. If demand if demand falls short of supply, then we have excess supply, and then we will have very low electricity prices, and the electricity prices drops down to 0. Or we could have excess demand, and then the price will jump up to a higher level, which I call uppercase m, which is higher than the lowercase m. So the higher the shortage, the higher the electricity price will be. Finally, there is going to be a cost of this situation where demand exceeds supply, a social cost, a blackout cost of the breakdown of the system if there is shortage of supply, which I call capital B for blackout costs. And to keep matters as simple as possible, blackout costs exceed the highest price that could ever be realized in the market. This is sort of the simplest way to establish that there's a missing money problem in that market. So the private incentives to invest are always lower than the social cost to avoid too little capacity. So this market, for whatever reason why we have, say, price caps, there's a missing money problem in the market. I do not explain that here, I just impose it on the model. Now, in such a simple world, there could be 3 kinds of outcomes that we want to think about. The first outcome would be we add capacity in the south. If we add capacity in the south, then we have 2 units of capacity in the south. Demand can either be 1 or 2, so there will never be excess demand in the south. And as I explained, in the north, there's never excess demand. So if we add capacity in the south, the world is fine in terms of reliability of the system. We always have enough in generation capacity, and we do not need additional network. If we build additional network in the north, if we build 1 additional unit in the north, this is useless unless we also install the link, because then we would have 2 units of capacity in the north, but demand in the north will never exceed 1. So we have to bring the additional capacity to the south by building the link. So the second outcome would be that we have, which I call NL, we have an additional generation unit installed in the north, and we build the additional link. Why would we ever do that? Well, it could well be that it's very cheap to build additional capacity in the north. So it's far cheaper to build capacity in the north than in the south. So the sum of the investments of building capacity in the north plus hooking it up to the southern region it's cheaper than adding capacity in the south. And finally, it could well be the case that we just build the link and do not add capacity in order to use the portfolio effects between the two regions. Okay, and depending on the parameters of the model, one of these three outcomes is most favorable. Now, the point that I want to make is we face the challenge that we have to make up our mind which of the three outcomes, where to build capacity, and if we build capacity, should we also extend the grid? This is a challenge that, well, a regulator, say, or social planner, I just call it now the regulator, faces. And the question is, what can a regulator actually do? The regulator might control the decision on building the link because he then says, okay, there will be investment budget for building the link, and then the TSO can build the link. This is sort of what I would say. That's the status quo in Germany, at least. Or additionally, the regulator might provide incentives for building generation capacity, giving capacity payments, say, locationalized capacity payments. This is not the status quo. This would be a sort of a regionalized capacity market. This is what the regulator can do. Now, what does the regulator know? You also alluded to the problem. I mean, there are loads of asymmetric information problems, lots of uncertainties. And, well, the regulator might know exactly the cost of how much it costs to add capacity in the north or in the south, but it's not so clear that he actually has this information. Who knows what offshore wind farms will cost in the North Sea? I think the investors do not exactly know, and I'm quite sure the regulator does not know either. So there's the danger of an asymmetric information problem. And finally, it's questionable what is the commitment power of the regulator. Now, currently, it seems to be that the regulator, in developing the network or allowing additional investments and financing that with investment budgets, follows the private investment decisions of the generators. So generators build up additional capacity in the North Sea, and then the regulator says, okay, in order that these investments make sense, I have to follow up by upgrading the network. It's not so clear that this is how it should actually work. Shouldn't it perhaps, in an integrated view, both decisions where to locate the plants and where to add the network should be integrated? Now we have a first mover, so to speak, by the generation, and then the network follows, although with a large lag, as we all know. But once the generation is located somewhere, the idea is the network must follow. It's not so clear that is the way it should work, or that this is the most efficient way it works. So there are two, from an economic perspective, there are two typical economic problems. The first is the information problem, what does the regulator know? And the second is, what can the regulator commit to? Could the regulator ever commit to say, I'm not going to build additional network? Even if you build additional capacity in the north, or if you build too much additional capacity, from my point of view, the regulator, you build too much capacity there, well, bad luck, I'm not going to build additional network. At least not on regulated terms. This is probably not very realistic, at least in the current scenario. Now, there are different difficulties that can arise in that simple world. The first, I cut that short. If there is no information and no commitment problem for the regulator, I already said this market, I impose on that market a missing money problem. So as there is a missing money problem, we could have too little investment in capacity. This is sort of too trivial to talk about that. Now what becomes more interesting is, now if the regulator controls only the decision on the network, which I would say is, as I mentioned, the status quo, has perfect information about all the costs, how much the link costs, how much the addition of generation costs, but has a lack of commitment. That is, generators move first, and then the network decision follows, given the generation investment decision. Then we have two kinds of inefficiencies here. The first I call investment forcing effect. Now, it could well be the case that in the first best, it would be the case that generation capacity is added in the south. It's cheapest to build additional capacity in the south, then we would not need additional network in my simple model. By and large, it also holds for Germany. So if we would add loads of capacity in the south, we would need much less network. Okay. But from the private investor's perspective, things could be different. For the private investor, it could well be the case that for him it's more profitable to add capacity in the north, and then relying on the fact that the regulator will follow by imposing that the link will be built and the cost is going to be socialized, that we have an investment forcing effect. So the generator moves first, builds capacity at the inefficient location, and he can rely on the fact that the network is going to be built to hook up this additional capacity. And this is probably the most relevant case. We could also have the opposite effect, but I cut that short here. It could also have an investment preempting effect in terms of investment in the network. This is a pure problem of commitment, so it has nothing to do with information problems of the regulator. Now, if we add an information problem for the regulator, that is, the regulator does not know exactly the cost of generation, say in the north. So it's not so clear for the regulator what are actually the costs of building additional capacity in northern Germany. What are the costs of an offshore windmill? Which is going to build by 2015 or something, or 2020. Now, in that case, the regulator faces uncertainty, and the uncertainty in this little graph is reflected on the horizontal axis. So there's increasing asymmetry on information, that is increasing uncertainty about the cost of how much it actually costs to build capacity in the north. Now, as the asymmetry of information problem increases, the impact of the three different sort of commitment choices or commitment options of the regulator, or the costs of that, varies. So what are the different sort of things that the regulator could do? If he would have full commitment power, so in the sense he could move first, he could either say, well, given what I know, I will always build the network. This is the only thing I can control. I will always build the network, independent of what the private investors are going to invest in generation. Or he could say, I will never build it. Or he could say, well, I wait and see, I let you move first, and depending on what you do, I'm going to follow. We know that this causes inefficiencies from the slide before. We know that if the regulator cannot commit, then this causes this investment forcing effect, which causes inefficiencies. Because the private incentives where to locate the power plant is different from the social incentive. And why is that? Because in this simplified world, and also in the current regulatory regime, the generator does not carry all the follow-up costs that he causes on the network from his locational choice. Okay, so if the regulator cannot commit, we talked about that. If the regulator can commit, never or always to build the link, he has more commitment power. But what this graph illustrates is that this does not solve all the problems. That if he has full commitment power, he has to choose either never or always to build the link. But if he has asymmetric information, it could well be the case that the cost of the total system will be lower if he does not commit compared to if he commits. So how to read this is, since these are the expected system costs, is, well, the lower the better. So if the asymmetry information is small, then the regulator, under certain parameters of this example, should commit never to build the link. But as uncertainty becomes larger, he should at some point say, well, I'm not going to commit, even if I could, I wait and see, running to the danger of the inefficiencies I just mentioned. Why would the regulator ever want to do that? Because he has now two problems. He has the asymmetry of information problem and the commitment problem. And as the asymmetry of information problem becomes larger, it becomes important for him to wait and see where the generators are going to move, because this reveals him some information where it is cheap to add capacity. So this is, and I think these are basically the two of the main problems that a regulator faces: a commitment problem and an asymmetric information problem, and these two problems interact. Ultimately, one could think about the possibility that the regulator can not only control the network investment decision, but also can provide incentives where additional generation capacity could be located. And in the simplified model, there's a simple way to implement the first best here, but I'll cut that short. Now, because it's not the current regulatory situation. Now, what I wanted to stress with this little example is that there are these two kinds of problems. There's asymmetry of information, so the regulator lacks information about important element of system costs, and a lack of commitment. The regulator might not be able to commit long-term to a regulatory rule how to deal with network extensions. And this implies that there's a general trade-off between these two effects, because if I have asymmetry of information, if I have little information as the regulator, I need to see what the market does because I can elicit information from that. But if I wait to see what the market does, the market knows that he can anticipate that I will elicit information from his behavior and can strategically behave and then exploit my limited commitment. This happens even in the case when we have nodal pricing. This was a model of nodal pricing. We had only two nodes, but of zonal pricing, say, for practical purposes, of a northern zone, say, in Germany, and the southern zone. Now, we know that this is not the case in Germany. We don't have that, but we have a single market zone in Germany, and so we know that there are network restrictions, and currently we solve these network restrictions by we impose a uniform price regime in Germany, and we solve the network problems by redispatching the power plants. This is an important design aspect of electricity markets, whether we will have regional prices or not. I don't see that at least Germany will go towards a zonal pricing regime. Then let us for a moment think about what implications would it have if we stick to a uniform price zone, large uniform price zones, using the example of Germany once again. Now, if we stick to our current system and we again do our simulation analysis, what would that impose on the regional level on dispatch? Again, there are loads of assumptions behind these calculations, but I think they give a good indication, qualitatively at least, what is going to happen. Now, it doesn't come as a surprise that we're going to have a lot of congestion, so the percentage figures here are the percentage shares of hours where lines are congested. And so you will see that there are significant number of hours of congestions, in particular in the north, but also in particular lines in the south. We will have significant redispatch and increasing redispatch over the time. These are now simulations for 2025. In a world where we have all these additional renewable additions to meet the German targets. Perhaps it's interesting to see that redispatch has a clear seasonal structure. So there will be loads of redispatch in the winter half year and far less redispatch in the summer. It has to do with the wind in feed that is higher in the winter than in the summer. Now, this is what we need as redispatch in the current system. That's an order of magnitude. Now, where does it come from? Well, we will have the need for redispatch for reducing generation in regions. Well, where do we have to reduce generation? It will be in the north. Where will that come from, the reduction in generation? Well, if we have these loads of wind there, it will to a large share come from the reduction of infeed from wind power plants. Increasing generation, well, obviously is far more difficult, and we cannot rely on renewables here, so we have to rely on conventional power plants, and the most important part on that slide is the gray technology here. So the dark one is, the black one is coal, the brown one is lignite. Well, there is no nuclear in 2025 in Germany left. What is the gray? Yeah, what is the large gray share here? So you can't read that, but perhaps on the printout you can read what's written there is a dummy, which just says we don't know. We need that, but it doesn't exist. So this is, we will have a shortage of, or we will have an additional need of capacity which is able to supply this redispatch capacity. And this again is a regional dimension. And again, like in my simplified example before, the regional dimension always then brings up the question where to locate and how to hook it up to the network. To conclude, what I wanted to stress is that regional aspects become increasingly important, and that regional aspects, I mean, we have illustrated that on the German example, but I think it holds true not only for Germany, but for the whole European Union and for most member countries. Regional aspects become increasingly important. As regional aspects become important, the coordination not only of the size of investments in terms of capacity markets or capacity mechanisms is an issue, but the coordination, where to locate it and how to coordinate that with the grid extension becomes increasingly important. With the two main challenges that I stressed here is the asymmetry of information. What are the costs for generation capacities at different locations, and what is the commitment ability of the regulator or whoever will be the central planner deciding on that, on the commitment power for the network development. If we do not have zonal pricings, we see the additional challenge in terms of the redispatch, the last point I mentioned. And perhaps this is not part of the analysis, but the last bullet is more sort of a hope, or perhaps food for thought or food for the discussion. Is, I mean, I've talked a lot about, I mean, the regulator does this and that, but I think there's a lot of scope for private or at least regulated incentive-compatible mechanisms that allow for more market in that system, and I think it's worthwhile thinking about these kinds of to putting in or to allowing for more private investment incentives to coordinate the location of generation and to coordinate the extension of the grid. Thank you very much for your attention.